Hi everybody, my name is Christopher Abrego. I am a PhD candidate in the Department of Mechanical Engineering at UT Arlington, and today I'll be talking to you about my TAR project titled Smart Braking Experiment for Undergraduate Mechatronics Exposure. Next slide, please. So essentially what I wanted to achieve here is to provide undergraduate students with a hands-on learning experience in an effort to improve their conceptual understanding of a controls course. Undergraduates in the Mechanical Engineering Department during their last semester, take a course in control theory, and this course is notorious for being difficult due to its abstract concepts. So essentially my hypothesis was to expose students to a mechatronics experiment, mechatronics being the combination of both mechanical and electrical engineering, and see how well they performed based on the exposure to this experiment. Next slide, please. So essentially the project took place over a period of 3 long semesters. The experiment itself was staged in 3 phases. So a student first learned actuators, then the student learned sensors, then put it together and learned systems, and then incorporated some controls concepts to get a better hands-on experience on what exactly these terms mean in the classroom. Here on the right-hand side, let me see if I can use a laser pointer. On the right-hand side, we see the actual setup. It's basically a carriage, and on the carriage rides on a track. And essentially what we're doing here is that we're mimicking the smart braking feature found in contemporary cars, which helps prevent collisions. So we have some sensors here running on a motor, and then we developed some algorithms that, using control theory, will help prevent collisions. This assessment techniques I used were pre-survey, a post-survey. I asked students to give me a lab write-up a week later, and then I also collected their grades at the end of the semester. Next slide, please. Okay, so among some of the results I wanted to provide today, objectively, once I collected their grades, I have them displayed here. On the horizontal axis are the categories of the grades, just A, B, C, and D. And then horizontal axis we have the percentage of students. 2 columns represent students that have taken controls. So on the left-hand side of each category are students that have taken controls course, but did not concurrently take the experiment. So the experiment was not used here to supplement their understanding. And on the right-hand side is students that were taking the controls course, and at the same time were performing the experiment to supplement their understanding. Some things to note real quick is students that make A's, they're probably always going to make A's regardless if they get supplemental information or not. However, I'd like to focus on category B and category C. For students that were taking the experiment at the same time that they're taking their course, we see a higher majority of those students made B's as opposed to C's, where the opposite is true. Students that were not exposed to this experiment did not make as many B's as in C's. Again, I'm assuming a lot of things here that the experiment directly correlates to the student's final grade. Next slide, please. So that was objectively. Not subjectively, I also, in the post-survey, asked some students some questions, and among some of them I'd like to present here. When I asked students, when would you like to perform this experiment if given the opportunity, we're looking here on the left-hand side, the overwhelming majority said that they'd like to perform this experiment concurrently or before, further supporting our hypothesis that students need to be exposed to a more hands-on approach to supplement what they're learning in the classroom. And then on the right-hand side, we have another pie chart. I asked students, this is a pretty ambiguous question, but did your knowledge and controls improve after you performed the experiment? And again, the overwhelming majority agreed that yes, my knowledge is improving. Then again, I mean, it depends on what students understand with the words improved and knowledge as well. Nevertheless, I mean, this gives us a good understanding that students here both feel like this is necessary, as well as they subjectively feel that they are improving their knowledge in controls. Next slide, please. So, in conclusion, some of the things that we can derive from this information is that students would like a controls lab, so kind of like a lab lecture section, or exposure to like a mechatronics experiment during their controls course. Moreover, just to supplement what they've been learning in the classroom. Some of the things I learned personally, the IRB process, I've never been through their process, so I was able to go through it. Effectively teaching students at different, with different backgrounds, different levels of education, setting up experiments as well, writing a lab manual, something that I haven't done before and requires a lot of detail. Some of the things I'd like to do in the future, I'm sure a lot of people could agree with this. It's hard to get people to respond to surveys once they walk out of the lab or once they walk out of the classroom. So I need to get better track of students to actually fill out the surveys. And I'd like to also perform this experiment on a more focused group of students that learn better with hands-on and see how well they performed. Next slide, please. And I just want to acknowledge some people at this point. I'd like to acknowledge Lisa Berry, Dr. Jim Grover, Dr. Pana Shikolas. These are members of the steering committee for CERTL here at the university and have helped out. Dr. Shikolas is the actual professor of the lab where I implemented this experiment. I also want to recognize funding for purchasing equipment and time. And then I want to recognize students in the course ME 3182 for volunteering to take this experiment. Next slide. So this concludes the presentation. Open the floor to any questions, if any.
Great. We have plenty of time for questions. And again, there's multiple ways of asking questions. You can raise your hand if you're willing to speak up. Or you can type directly on the slide using the toolbar. The fourth button down is the text box. You can type onto there. You can also type into the chat window. So while we're waiting for people to type in some questions, I have a question. So, and it might just be that I missed it. This experiment was it wasn't a full course in addition to the controls class that we're taking, right? How long were they doing the hands-on experiment for, and did they get credit for it?
Great question. So essentially, we wanted to provide this as a volunteer basis. Students take a course, a lab course, where they're exposed to a lot of conceptual ideas, but now they put it in practice in experiments. So I asked the professor if I could actually introduce a new experiment that would supplement what they're not learning in control. So again, this was a 3-hour period where the students had the option, if they wanted to, they could take this course. And out of every student asked for 3 long semesters, we had them. I think only one group objected to taking the experiment. So I mean, it was very attractive. We're bringing a technology found in very modern cars, which is smart braking, and we were trying to reduce it to a level where students can understand how exactly these components work. So yeah, it was all on a volunteer basis, and they were given a period of 3 hours to apply what they've learned or what they were currently learning in their controls course.